Hello everyone, I am your friend Shadab Imam and we are continuing our lecture series on operations research. If you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. Today I have came up with another variation in a transportation problem. So let us see the problem first. The problem says that the transportation cost per unit from sources to destination is given in the table below. So this is the matrix where 1 2 3 these are sources and these are destination, and this is unit transportation cost from source I to destination J with having certain supply and certain demand. Now it says that suppose there are penalty cost for every unsatisfied demand unit which are given by 5, 3 and 2 for destinations 1, 2 and 3 respectively. That means there is a penalty for unsatisfied demand unit for destination 1, 2 and 3, and they are 5, 3 and 2 respectively. So now let us first see that our problem is balanced or unbalanced. That means the total supply is equal to total demand or not. So let us see here. This is 80, 90. This is equals to 105, 105, and this is 25, 125, 145, 145. So as we can see here that the supply is less than the demand. So this is an unbalanced problem and we need to balance the problem. So what we will do is we will add a dummy row of supply 40 so that our total supply will be equal to total demand. So here I have written these are 3 supplies and this is our dummy row which is having the supply of 40. Now if we calculate the total supply, this is coming as 145 and this is also coming as 145. So now our problem is balanced, and usually what happens whenever we are adding a dummy row or a dummy column, we will take the unit transportation cost as 0. But in this particular problem it says that there is a penalty cost for every unsatisfied demand unit. So there is a penalty for each unit that is not fulfilled. So for destination 1 the penalty is 5, for destination 2 penalty is 3, and for destination 3 penalty is 2. It has been mentioned in the problem. So this time we will not take these transportation cost as 0, else what we'll do is we'll take here the penalties, so that if any allocation has been made in these 3 cells, then it will definitely increase our cost as it's added the penalty in the total transportation cost. So let us start solving. So this will be our cost matrix. And now first of all we will find the basic feasible solution, and we will find out the basic feasible solution by Vogel's approximation method. So for Vogel's approximation method we need to take the difference of least value and the second least value, okay, or I can say minimum value or the second minimum value in each row and in each column. So let us start from here. Minimum is 3, next minimum is 5, so penalty here is 2. Similarly here minimum is 1, next minimum is 2, penalty is 1. Similarly here minimum is 2, next minimum is 5, penalty is 3. Now moving on to the rows, we have minimum is 1, next minimum is 5, so penalty is 4. Here minimum is 4, next minimum is 6, penalty is 2. Here minimum is 2, next minimum is 3, penalty is 1. Here minimum is 2, next minimum is 3, penalty is 1. So now we will select the maximum penalty. So 4 is the maximum penalty, so we will select this, and in this row we will select the cell having the least cost, that means least transportation cost. So this is the cell, so we will try to allocate as much as possible in this particular cell. So we can see that here the demand is 20 and the supply is 10, so we can allocate 10 here, and after allocating 10 this will be 0 and no more allocation can be done in this particular row. Now again for the remaining matrix we will calculate the penalties. So as the row does not change, the penalties in the row will also not change, and we need to calculate the penalty in column. So this will be 3 minus 5 is 2. Okay, here minimum is 2, next minimum is 3, difference is 1. Okay, here minimum is 2, next minimum is 5, difference is 3. So I do not need to change this, and among these we can see now that the maximum penalty is here. So I will select this column, and in this column I will select the cell having the least transportation cost. So this is the cell, and I will try to allocate as much as possible here. So I will allocate 40 because out of 50 I can only allocate 40. So by allocating 40 this becomes 0 and no more allocation can be done in this cell. Similarly, now 50 has been reduced to 10. Now again we need to calculate the penalties. So as row does not change, the penalties does not change, and we need to calculate the penalties for column. So let us calculate the penalties again for column. So minimum is 3, next minimum is 6, penalty is 3. Here minimum is 2, next minimum is 4, penalty is 2. Here minimum is 5, next minimum is 6, penalty is 1. Now among these the maximum penalty is coming at this. So I will select this, and here 3 is the minimum transportation cost. So we will allocate 15 here. So this is 15 and this becomes 0. That means no more allocation can be done here, and this has been reduced to 60. Now as we have only one row remaining, we do not have any choice but to allocate the remaining values in these particular cells. So 60 has to be allocated here, 20 has to be allocated here, and 10 has to be allocated here. Okay, sorry, this is not 20, this will be 10 because we have already allocated 10 here. So out of 20, 10 has been allocated, so 10 will be remaining. So here it will be 10. Okay, so now this is our basic feasible solution where we need to have m plus n minus 1 number of allocations. So we can see that m is 4, n is 3, that means 4 plus 3 minus 1. So there should be 6 number of allocations, and there are exactly 6 number of allocation. Okay, so this is our basic feasible solution, and now we will check the optimality here. Now to check the optimality we will use the modified distribution method or MODI method, and so let us allocate these values here. So the allocations after basic feasible solution is 10, 60, 10, 10, 15 and 40. Now in modified distribution method we need to calculate the values of the variables, that is u1, u2, u3, u4, v1, v2, v3. Now to calculate the value of these variables we need to remember that for allocated cell we have Cij equals to ui plus vj. That means for an allocated cell, suppose this is the allocated cell, the value of Cij, that means unit transportation cost 1, should be equal to ui, that means u1, plus vj, that means v2. So if I consider this variable as 0, 0 plus what equals to 1, so I can easily say that 0 plus 1 is 1. Similarly, for this allocation, 1 plus what equal to 4, so we can say that 1 plus 3 is 4. Similarly, 3 plus what equals to 6, so 3 plus 3 is 6, and 3 plus what equal to 6, so again this will be 3 plus 3 is 6, and this is 3 plus what equal to 3, so 3 plus 0 is 3, and this is 3 plus what equal to 2, that means 3 has to be 3 plus minus 1 equal to 2. Now we have calculated the values of u's and v's, and now we need to calculate the values at non-basic cells. Okay, so these are non-basic cells, and we need to calculate the value at non-basic cell as Cij minus of ui plus vj. So Cij is 5 minus 0 plus 3, that means 5 minus 3 is plus 2. Similarly, 7 minus 0 plus 3, that means 7 minus 3 is plus 4. Similarly, here 2 minus 0 plus 1, that means 2 minus 1 is plus 1. 5 minus 0 plus 3, that means 5 minus 3 is plus 2. Here 5 minus 1 plus 3, that means 5 minus 2, that means plus 3. 3 minus of minus 1 plus 1, so this will be plus 3. And now here we can see that all the values in the non-basic cell are coming as positive. That means even if we allocate a single quantity in these cells, our overall transportation cost per unit is going to increase by these values. So it shows that we cannot improve our solution further, and this is the optimal solution we could get here. So this is the optimal solution, and we need to find the value of z, that is z minimum. So z minimum will come as 1 into 10 plus 6 into 60, so this will be 360 plus 40, 400, 460, 470 plus 30, 470 plus 45, that means sorry, this is okay, 60, 360, 400, 460, 470 plus 45, 60, 360, 400, so this will come as 595. This will come as 595. So this is the value of z we have obtained, and for this value of z, the optimal allocation is this one. So this is another variation in the unbalanced problem where we do not have the value 0 in the dummy row or dummy column. Instead of that, we have penalties that is given in the question. So in the coming lectures, we will do some more questions on transportation problem. If you like the lecture, please share the lecture. Have a nice day. Thank you.